Welcome back to video number 4. Our goal for today, given an equation, you will be able to change it by following a rule and then describe how it affects the picture of the function on a graph. Okay, so today we're going to be changing the equations and we're going to be looking at its graph. All right, so let's go ahead and take a look. Now you're going to want to watch very carefully today. All right, this can be a little bit confusing, but hopefully we're going to go step by step through it and you'll be able to find strategies that work for you. Okay, so number 1, explain each of the situations below given the mother function f of x equals absolute value of x. So the mother function, this means this is our base function. This is what we're going to start with. So everybody, let's start by putting that in our calculators. So to get to the absolute value, I hit second catalog, which is my 0 down there at the bottom, catalog. ABS, absolute value, is choice 1. I type in an X and I hit graph. Okay, so this is going to be my parent function, my mother function, my base function. Okay, so let's put that off to the side. All right, so what we're going to do, first we're going to change the equation, which I like to call it manipulating the equation. And then we're going to look to see how it affects the picture on the graph. Okay, so let's take a look here. If g of x equals f of x plus 2, how is the graph f of x translated to form g of x? So the first thing we need to do is we need to figure out, well, what is g of x? We know that f of x is going to be the absolute value of x. So f of x equals the absolute value of x. So what we need to do is we now need to find g of x, okay? And now g of x is equal to f of x plus 2. Now look to see what's inside of the parentheses. We have an x plus 2 inside the parentheses. Now look at your regular f function. What's inside the parentheses? It is an x. And then we see that we have an x here. So what we want to do to get f of x plus 2 is wherever you see an x, we're going to substitute in x plus 2. So our function g of x is going to be, instead of the absolute value of x, it's going to be the absolute value of x plus 2. And we have just found our new function. So we've changed the function. Now that we've changed it, we want to look to see how it is affected on the graph. So let's go back to our y equals. We're going to keep absolute value of x in the first one, and now we're going to go down and we're going to do the absolute value, second catalog, absolute value, and now we're going to type in x plus 2. Now think, we're adding 2 to the x. What do you think that's going to do to the function? Well, let's see. Hit graph. So what did it do to our function? Well, it looks like it moved it 2 units to the left. Ooh, I'm sorry. Excuse me there. So how did it change? Well, let's see. It translated 2 units to the left. So by adding 2 to the inside, we moved it 2 units to the left. Okay, so let's see what happens for our next one. So for part B, it says if g of x equals f of x plus minus 2, how is the graph f of x translated to form g of x? Well, first we need to figure out what the equation of g of x is. So I'm going to start by writing f of x equals, and this is our parent function from up top, which is the absolute value of x. Now we want to write g of x. Okay, now g of x is f of x minus 2. So if we take a look here, x minus 2 is all inside of the parentheses. So if we take a look at our mother function, x is inside the parentheses. Now we want to put an x minus 2. So that means wherever we see an x, we're going to replace it with an x minus 2. So this is going to become x minus 2. All right, so now we have our brand new function. So let's take a look at the graph and see how is this going to change the picture. So let's go back to y equals. Okay, we already have absolute value of x. Now I'm going to change this instead of a plus x. Now I'm going to make it a minus x, and I'm going to hit graph. And let's see what happens. There's our regular, and here's our new function. So our new function, what happened? It shifted 2 units to the right. So we can write translated, or we can write that it shifted 2 units to the right. All right, so when we add 2 inside of the function, it moves 2 units to the left. Now in our heads, usually we think that that's going to go to the right, but because it's inside, it's doing the opposite, so it goes to the left. And if we subtract, it's going to go to the right. All right, so let's see what happens now for part C. So now we have if g of x equals f of x plus 5. How is the graph f of x translated to form g of x? All right, well, the first thing we need to do is we need to write our new equation. So I'm going to start by writing my old equation. F of x is equal to the absolute value of x. So now we have to write our new equation, g of x equals. Now let's look to see the definition. So g of x equals f of x plus 5. So are we changing the function f of x? Well, no, there's still only an x inside the parentheses, just like there's an x inside the parentheses. So I know that this whole thing right here is actually equal to the absolute value of x. So I'm going to keep the absolute value of x exactly the same, but what we're going to do now is we're just going to add 5 to the end of it. So f of x, so it's the function plus 5. So I just add 5. And now we've created our new function. So let's go ahead and look to see, well, what happens. So I'm going to go back to my calculator. I'm going to keep my mother function as the first one, and now I'm going to do absolute value of x, and I'm going to go over, and now I'm going to hit plus 5 and hit graph. Let's see what happens. Ooh, so what happens? It moved, or it shifted, or it translated. This time it goes up 5 units. So we're going to write it translated 5 units up, and we've got it. All right, so let's take a look now at our next one. If g of x equals f of x minus 5, how is the graph translated to form g of x? Well, first, let's write our function. So f of x is equal to the absolute value of x. Now we have to write our new function, g of x. Now g of x is equal to f of x. Now we're not changing f of x. We want to keep f of x exactly the same, but what are we going to do to it? We're going to subtract 5 at the end. So that's going to be absolute value of x minus 5. And there's my new function. So let's go ahead and see what happens. I'm going to go to my y equals. I'm going to change that plus to a minus. I'm sure a lot of you can probably guess what's going to happen. But we are going to shift down 5 units. So we are going to shift down 5 units. So whenever you explain it, you always want to say exactly what direction you're going in, and you want to say how many units you're going in. So direction and how many units. So here we did how many units, we did direction. We did direction, how many units. So we did that for all of these so far. Let's go ahead and take a look now at E. So if g of x equals negative f of x, how is the graph changed to form g of x? Well, first, we need to make sure that we can write our function. So let's write our new function, g of x. This time, again, I did not change the parentheses. So the function is going to stay the same, but what am I going to put in front of it? We're going to put a negative x in front of it. So negative absolute value of x. And let's see what happens when we do that. So I'm going to go down and clear this out. So negative absolute value of x, and I'm going to hit graph. So there's my mother function, and there's my new one. So what happens? It reflected over the x-axis. A lot of us like to say it flipped. So you could say it flipped, but the mathematical word is reflected, and you always want to say how it reflected. It reflected over the x-axis. Now let's take a look at our next one. So g of x equals 5 times f of x. So let's start by writing our function. Now we want to write our new function, g of x. All right, so this time it is going to be 5 times f of x. So we're not changing f of x at all. We're keeping it the same, but what are we going to do to the front? We're going to multiply it by 5. So this is 5 absolute value of x. All right, so there we go. Let's see what happens when we do that. So I'm going to come down here. I'm going to change that negative to a 5 and hit graph. So there's my original, and here's my new one. So what happens? It becomes narrower. All right, if it becomes narrower, so a lot of us like to say it's narrower or it's skinnier, but what does that actually mean? It means it grows at a faster rate of change. Okay, now here's the challenge one. All right, our last one. G of x equals f of x minus 1. Oops, oh, there's a typo here. This is supposed to be a minus 5. I apologize. It's supposed to be a minus 5, so please fix that. Minus 5. You can't have two equal signs. So how is the graph changed to form g of x? Well, let's start by writing our function, our parent function. Okay, now we have to write our new function, g of x. So if we take a look here, we are actually changing the inside of the function. Now we want an x minus 1. So that means inside of the function, instead of an x, we're going to put x plus 1. But also, what are we doing to the end? We're subtracting 5 from the end of it as well. So now let's take a look and see what happens when we do that. So I'm going to go down here, clear out this next one, and then I'm going to go and put second catalog absolute value, x minus 1. I'm going to go over and then subtract 5. Hit graph. Ooh, so what happened here? So it looks like it went to the right one and down 5. So if I look at the vertex, it went over 1 and down 5. So all of your points are going to be shifted 1 unit right and 5 units down, and we've got it. And that, ladies and gentlemen, is as complex as it gets. All right, so let's go ahead. We're going to flip the page over. Now, sometimes you're going to see these questions, and often we're going to see them, I should say, as multiple choice questions. So kind of a multiple choice strategy when solving these is you always just want to plug it in and look at the picture, because the picture will help you figure it out. So let's take a look now at number 2 here. Starting with the graph y equals x squared. Which function below will shift the graph 4 units down and will make the graph wider? Well, let's go ahead and let's try it out. So I'm going to clear these out. So my original function is x squared. Okay, so I know if it's squared, it's going to be a parabola. I want to know which of these is going to shift it 4 units down and make it wider. Well, I know if it's going to go down 4 units. I know that it's going to have to subtract 4, because when you subtract 4 at the end, that's what shifts it down. That's what we learned on the front. So automatically, I'm going to cross off A and B. So I'm going to go ahead now and I'm going to start with choice D. I'm going to start at the end and work up. So I'm going to go 1/2 x squared minus 4. If I wanted to, I could plug them all in. So I could also do 3x squared minus 4. So I guess I'll plug them both in, and then I'm going to hit graph, and it's going to graph them in the order that I typed them. So here's my first one. There's my second one. And there's my third one. So which one shifted 4 units down? Well, both of these, but which one made it wider? Well, that was the second one that graphed, and that was choice D. Okay, we're going to run out of time. Question 3 is very similar, so what I'd like you to do is just take a look at our homework for tonight, finish this, and be ready for class tomorrow. Have a great day, everyone.